Hello guys, in a new video. In this video I'm going to discuss or explain a new physics theme which is about the periodic motion and its division. In the following videos I'm going to explain more widely about the periodic motion and its divisions. First, don't forget to like and subscribe in my new channel. First, what is the periodic motion? It is a motion which is regularly repeated in equal periods or intervals of time. And the periodic motion can be divided into two types. So the periodic motion has two types, which are oscillatory motion. I'm going to discuss it in this video, and wave motion. In the next video I'm going to explain it. What is the oscillatory motion? It is a periodic motion of oscillating body around its rest position or rest point, where the motion is repeated through equal intervals of time on the both sides. So, oscillatory motion, we said that is a type of periodic motion of oscillating body moves around its rest position or its original position, where the motion is repeated through equal intervals of time as the definition of periodic motion. Then, on the both sides, move on the both sides of its original position. There is also a relation between the velocity of oscillating body and its kinetic energy, which is as an equation: kinetic energy equal half mass multiplied by velocity power 2. It will not be so important because we are not going to use it. So we deduce yet from that law that the kinetic energy is directly proportional to the mass and directly proportional to the squared the velocity. Note number 1, the velocity of oscillating body decreases as it goes far from its rest point until it reaches zero at the maximum displacement. Number 2, the motion of rotary bee is a periodic motion as it is repeated in equal intervals of time, but not oscillatory motion because it doesn't repeat on the two sides. So there are two rules for making an oscillatory motion. The first, it is regularly repeated in equal intervals of time, and the second, to be repeated on the both two sides of its rest position. And now some example of oscillatory motion as the tuning fork, pendulum, spring, the motion of the swing, stretched string in the guitar. Now I will discuss the graphical representation. First, I will tell you a test you need. All things you need in this test is a smooth paper taped, rolled around 2 rolls, spring, weight, holder, and pencil. The steps: fix the pencil to the weight with a tie, and then tie the weight once on end of the spring. Tie the other end of the spring at the holder so that the pencil tip touches the midpoint of the paper. Roll the paper tape regularly, then pull the weight downwards and leave it. What will you see or your observation? The pencil draw the shape of some of the oscillatory motion on the paper tape as shown in the figure. The conclusion: motion of the weight, which is called the simple harmonic motion, is considered the simplest form of oscillatory motion, where the point A is the rest point, then C is the highest point, which is known in the second video as crest, and B is a trough. Note, in the simple harmonic motion, the velocity of oscillating body is inversely proportional to displacement away from its rest position, H is A. Now, after the note, we are going to see the properties of oscillatory motion. The property of oscillatory motion has 4 themes, which is amplitude, complete oscillation, periodic time, and frequency. First, or number A, is the amplitude. The amplitude means the maximum displacement done by oscillating body far from its rest position and its measuring unit is in meters. And there is a figure in front of you which is a representation of the amplitude, the maximum displacement that pendulum makes when it oscillates around far from its rest position. So the displacement A, B, B, A, AC and CA are equal to each other, which called amplitude. Now after amplitude we are going to point B, which is complete oscillation. The complete oscillation is the definition. It is the motion of oscillating body when it passes by a fixed point on its path twice or two successive times in the same direction. Or in another word, the complete oscillation is 4 amplitude, or the amplitude is 1/4 complete oscillation. Now to point C and D together, because they are inversely proportional or inverse to each other, which is periodic time and the frequency. The periodic time, it is the time taken by oscillating body to make one complete oscillation, or 4 amplitudes. The measuring unit of it is second, and the rule to know it, the rule between of the periodic time and the frequency is inversely, and so important to solve many problems. The periodic time rule is periodic time equal time over a number of complete oscillations. Now to the frequency, which is point D. The frequency is the number of complete oscillation made by oscillating body in 1 second, and each measuring unit is Hertz, related to the German scientist who discovered it, Hertz, and its law, frequency equal number of complete oscillation over the time. After we have finished all these properties of oscillatory motion, I'm going to tell you a small 2 points. They are so small. The first, the fraction of Hertz. Hertz, as the centimeter, have millimeter, nanometer, and etc. Hertz has the same thing, but Hertz, kilohertz, megahertz, gigahertz, ascendingly. Hertz, to make it to be in kilohertz by 10 to the power negative 3, but to translate from kilohertz to hertz by 10 to the power 3. And you will see the image. You can stop the video and see it widely. Now the relation between the periodic time and the frequency. I told you before, the periodic time is the time in seconds over the number of complete oscillation. The frequency, which is number of complete oscillation over time in seconds. So when we multiply the periodic time by the frequency, it will produce 1. From this, the periodic time equal 1 over frequency, the frequency equal 1 over periodic time, and the frequency is inversely proportional to periodic time. This is all for this video. If you want more, you can see in my channel. Don't forget to like and subscribe. In the second video, I'm going to tell you more about the wave motion. Then we can make about videos about computerization. Thank you for watching.